So the notes that we're going to look at now is over direct variation. You guys have seen direct variation in Algebra 1. I know that was a couple years ago for some of you, but you should remember direct variation. I'll give you a hint. The direct variation equation is y equals kx. This is your direct variation equation. What does that direct variation equation mean? What does it give you? What does it do? Let's start simple. Does it have a y-intercept for y equals kx? Yes or no? Okay, so if I don't have a y-intercept, what does that mean? It needs to be some number. So what do we usually represent with nothing? So the y-intercept is 0. The k-value is in the same place as your m. So it's very similar to your slope. Your k-value is not exactly your slope. We call your k-value your constant of variation. It's very similar to your slope, but it's not exactly your slope. Because in order to find that constant of variation, you're not going to take 2 points and find the slope from it. You're actually going to pretty much look at the ratio between x and y, but we'll talk about that later on this page. So here's your direct variation equation. It doesn't have a y-intercept, and the k-value is very similar to your slope. It's in the same spot. So for the problem, or for the part down here, we're going to look at 6, 7, and 9. And I'll help you with number 6, but you guys will do 7 and 9. So for question number 6, it looks like it's in my y equals kx form. So my question to you guys, is this a direct variation? Does it have a y-intercept of 0? Yes, it does. There's literally no y-intercept, so I could put a plus 0 at the end. You don't have to, but there's literally no y-intercept. When there's no y-intercept, it's a direct variation, which means it has to go through the origin. When it says that it has a y-intercept, I'm going to put this in parentheses. It goes through the origin. So that's kind of important. It goes through the origin, hence the y-intercept being 0. You should know that, but I know it's hard for some of y'all sometimes. So I get lazy. dv represents direct variation. It says in the directions, if it is a direct variation, give the constant of variation, which is very similar to your slope. If I was asking you guys for the constant of variation, Michelle, what would you tell me that constant of variation is for this? For this equation. What's our constant of variation? Not 1. What's being multiplied to x? What's being multiplied with x? Square root of 5. Even though it's behind your number, it's still okay. So your constant of variation is just the square root of x. Or excuse me, square root of 5. The x that has it, it's literally attached behind it for this question, but it's still your constant of variation. It's acting as your slope. So right now, you guys are going to do numbers 7 and 9. Determine first if it's a direct variation, so does it go through the origin? And if it is, give me the constant of variation. If it's not a direct variation, obviously just put no dv for not direct variation and then move on. So right now, you guys are doing number 7 and 9. I'm going to give you a quick 2 minutes. All right, let's look at question number 7. Okay, so Michelle, even though I talked to you briefly about number 6, for number 7, is that a direct variation, yes or no? Yes, it is a direct variation. So what's the equation that you got when you simplified it? After you distributed and isolated y, what'd you get? So yes, this is a direct variation. And what's the constant of variation for this? 8. Don't give me the x, just give me the 8. Perfect. All right, Tristan, for number 9, what's the equation for your, equation here?
Equation? Oh,
y equals 4. Is that a direct variation? Okay, so if I was to graph this out, what would it look like? What is that? Is that horizontal or vertical? Horizontal. So it would be a horizontal line going through 4. That would be y equals 4. So for this question, it's not going through the origin, and it really doesn't have a slope. What type of slope is this, though? Not undefined. Zero. This is a zero slope. So technically, one person asked me last class period, Ms. Tapia, what if you gave us y equals 0? Well, y equals 0 technically is along the x-axis, and it goes through the origin. I don't foresee myself putting a question like that on a test or quiz, but it technically is a direct variation. I have to double check it to make sure, but it actually is, because it goes to the origin, which means your constant of variation would be what? 0, because it's a zero slope. I don't foresee myself giving you a question like this, but just in case, you at least know. So for this question, back to the blue, this is not a direct variation. So this one is not a direct variation. All right, we have a couple more to look at. I will make a little kind of note right now. Direct variation, you saw it back in Algebra 1, you're going to see it now, and you're also going to see it at the end of the school year. At the end of the school year, I'm actually going to combine it with 2 other types of variation, but we're going to wait till the end of the year before we get to that. Since we've already talked about linear functions, that's why I'm picking this up now. Okay, the next part of this is asking, tell whether the data in the table shows a direct variation, and if so, write the equation relating x and y. Keep in mind, above I told you the constant of variation is very similar to the slope. It's not the exact same. So if you went through these and you were like, oh, Ms. Tapia, I could just pick 2 points and find my slope. That's not how this works, not for direct variation. If I want you to show that something's a direct variation, what I'm going to ask you to do is I want you to compare the ratios of y over x for each of the terms that are in your table. So to show that you have a direct variation, I want you to compare the ratios of y over x. So it's not going to be a quick find the slope and move on. It's actually going to be look at the ratios that it creates. So for y over x for the first one, I'm going to create this as 1 over 2. Can 1 over 2 simplify? Okay, no, that's it. I'm done. The next one is going to be 2 over 4. So underneath it, I'll put 2 over 4. What does 2 over 4 reduce to? What do you notice? It's the same. Both of these are the same. So when you're finding if something is a direct variation in some kind of data for tables, you just want to see if this change, this ratio, is going to be the same for everything. So let's look at the next one. We have y over x, which is 3 over 8. So down here, I'm going to do this as 3 over 8. Can 3 over 8 reduce? Oh, that's gross. Okay, so what do you think? Is this going to be a direct variation? No, in order for it to be a direct variation, it needs to be a constant change. So just like the constant of variation, it has to be the same thing over and over. So this is not a direct variation. Once you have that, you're done. You don't even bother needing to check the rest of it. It's not a direct variation because of that stupid 3 over 8. With that in mind, we're now going to do the one next to it. And by we, I mean you. I'm going to help you start off with the first part, but you guys are going to finish it. So for this table over here, we're going to do the same thing. We need to identify if this is a direct variation or not. And we need to do so by comparing y over x. So I'll do one with you, but you're going to do the rest. Y over x is this ratio. So we're going to make this 2 over 3 divided by 10. We talked about this on the instantaneous and average rate of change stuff that we were looking at. How can I simplify this? Yes, ma'am. Keep, change it, flip it. We're going to put that 10 over 1. We're going to keep the numerator the same, change the division into multiplication, and we're going to flip or do the reciprocal of this fraction. When you simplify, you can multiply it across as 2 times 1, which is 2, 3 times 10, which is 30. What does 2 over 30 reduce to? That's the number to beat. Every single one of those ratios you create had better simplify to 1 over 15. If it doesn't simplify to 1 over 15, what is it? Not a direct variation. So right now, you guys finish it with the person next to you. Simplify it. The worst part is making sure you keep, change, and flip correctly. Give you about a minute. KCF, or some people say KCF for keep, change, flip, KFC. So I don't know how they do it. I just do KCF. It's okay. Keep, change, flip. All right, so if you take a second and look up for everything that I simplified, notice that they all reduce to 1 over 15. I do want to make a note. For this first part, I multiplied the numerator and denominator straight across to get this. Whenever you're simplifying, and this just goes back to you knowing how to do basic operations with fractions. Whenever you're simplifying here, you don't have to multiply straight across. I hate having to multiply and then divide. So if you can, within this little area, when you're multiplying two fractions, if you notice that you can reduce them or simplify, do that before you multiply it across. Because when you multiply it, it's just going to be one extra step to have to divide. So if you want to think of this as 4 times 1 over 3 times 20, that's why I'm reducing 4 over 20. Because 4 divided by 20 is just 1 over 5. That's why I'm doing that. If what I'm doing right now in red is too much for you to handle, all you have to do is multiply this across, and then divide. But it's up to you. So based on all of these being 1 over 15, is this a direct variation? Yes. And what's the equation going to be for this? That's not an equation, that's just a number. How would I write it as an equation? It'll be y equals what? Not plus 0. Just x. Yeah. I don't know if you said the x and I couldn't hear it. But yeah, 1 over 15x. You don't need to put the plus 0 at the end. You can, but it's not going to make a difference. On your tests and quizzes, this is what I want to see. All right, there's two last things I'm going to look at, which are 12 and 13. So for questions 12 and 13, we're going to look at them on the backside. For questions 12 and 13, I do want to make a little reminder to you. You technically saw how to do this back in middle school. You would usually set it up as a proportion. You would cross multiply. That's when you were probably introduced with the butterfly method. The reason why I don't recommend using the butterfly method for these questions is because of this stupid sentence here. Write the equation that relates x and y. When it says that, it's telling you to use the equation y equals kx. If you use a proportion, you will still get the exact same answer. However, most students struggle with trying to identify what's the k value. So, the way that you know it's a direct variation as well is because of this sentence. Y varies directly as x. That's going to tell you, kind of more supplemental help, to tell you that this is going to be a direct variation. Okay, so I have this information. I know I need to write the equation, and I know I need to also find, based on this last sentence, y when x is negative 5. What do I do? Let's start with the equation. How can I find the y equals kx for this information? Say it again, Vincent. Okay, and that's going to give me my k value. So what numbers am I going to plug in for y and x, though? Okay, 9 and 3. So let me actually plug that in. So the y and x value that's here, we're going to plug it in to y equals kx. I know I'm going to divide both sides by x in a second, but let me at least plug everything in so you know what we're doing. The y value is 3. The k is unknown. I'm going to find it. The x value is 9. So just like Vincent said, we're going to divide both sides by 9, which is going to give you 3 over 9. Vincent, please don't tell me 3. What's 3 divided by 9? 1/3. There you go. I always have one student that tells me 3. So on your equation, because part 1, which is what we're doing now, is writing the equation, we're going to write this as y equals 1/3 x. That's my direct variation equation. It's okay. The last part says, find y when x is negative 5. So the last step is to find y. When I find y, Omar, what should I do to find y? I know I need to plug in x equals 5, but where am I going to plug in x equals 5? For what equation? The result we got, the y equals 1/3 x. Take that x value and substitute it in. So Omar, go ahead and simplify that. 1/3 times negative 5 is what? It's okay. Make your life easier. Put that 5 over 1 and then multiply it across. No. Negative 5. No. Let's do this together. We're multiplying 5 times 1. What's 5 times 1? So we're going to put negative 5. And then for the denominator here, what's 3 times 1? 3. So what's your answer? Yep. Don't put it as an improper fraction or mixed number, guys. Keep it as an improper fraction because I don't like mixed numbers. So do the same stuff, but for question 13. Yes, I give you the fractions, but it gives you time to practice, so when you get to tests and quizzes, you don't be surprised. I just want to remind you guys really quick. When it says that your y is directly proportional to x, this is another kind of slap in the face that you could use a proportion, hence why it says proportional. But since it's asking you to write the equation, you can still use y equals kx. So I would still suggest use y equals kx. Even though it says it's directly proportional, once you see that directly, that's your kind of hint that you're going to use a direct variation. So finish solving it. Take a second, look up, make sure you got the right equation for your direct variation equation. It should have been positive 15 over 4. And then part 2 for this, you take that x value, x equals negative 5, plug it in, simplify. That should be your answer. Tristan just asked me, can you just write k equals 15 over 4 and be done with it? If I read the problem that it says right here, don't worry, I'll highlight it for you, Tristan. It says in pink right here, write an equation that varies or that relates x and y. Does this look like an equation that relates x and y? It's the k value, but it's not the relation between that. So especially if I ask you for this piece here, that's why I want you to write this equation out. Is that okay? Good question.